any of assignment 9.4?
Yeah.
Holy crap. What about the vocab?
We said we were coming up.
Yeah, we did the vocab.
Yeah,
We
that's
did the vocab?
We were caught up to that.
Hi. So we're caught up to where we started on my other classes yesterday. So, we have assignment 9.4, which covers hazardous air pollution, stuff that's bad for our lungs. Remember that we've talked about how the atmosphere works in general. Then we talked about how the atmosphere is changing because of human global warming. Now, the next section of the notes is how air pollution is bad for humans. Have we discussed human health consequences of air pollution?
Yeah.
So, number 26, I gave you the most common recipe for smog so that you would never forget it. Number 27, I talked about general effects of air pollution on humans and ecosystems. Respiratory and circulatory stuff, we did that yesterday. Someone needs to confirm this because I'm getting these messages. Yes? And that brings us to number 28, which is a 3-star study goal. There are 6 types of air pollution that are governed by the United States federal government. These are the criteria pollutants. We have criteria for them. Like when I have criteria for a hotel room, those are my standards. If I was going to say that all hotels have to have no bed bugs and clean sheets, those are my standards. That's my criteria for choosing a hotel. Likewise, please look up. The United States has standards. We have regulations for these 6 types of air pollution. Does anybody want to ask me anything about criteria in general? I will explain each of these in order. You have to know them. 3 stars, College Board always asks, and then we're going to build up on these when we go over here and talk this. Questions before I start? Please look up. PM stands for particulate material. There are particles. It's dust. The number is the size in nanometers. No, in picometers. I think it's. What is that symbol? Does somebody know what this symbol is? Is that nano or pico?
Let me see.
What?
I can't see it.
It is mu.
That's a micro.
1,000?
I'm saying that.
Micro? Whatever. It's very small. And so, these parts are 10 of those across. These things are 2.5 of those across. And the ones that are most dangerous, you have to know, are these ones. The really small stuff. The big stuff doesn't matter as much. Because the big stuff gets filtered by your nose hairs, by the mucus in your respiratory system. The big stuff doesn't usually reach your lungs. The little stuff does. So that's the ones that we worry about. Please look up. Normally you get dust from construction, logging, agriculture, and unpaved roads. But globally, the only type of particulate matter that's becoming more common is fine ash, like from coal burning power plants. We in Santa Barbara have very, very low particulate air pollution because we are very close to the ocean, so we have marine layer, which is like fog, which is like water, which is like wet. So particles usually get stuck to that water and fall to the ground. So watch me. 99.9% of the year, Santa Barbara particulate material is right around 0, some of the cleanest air on Earth. You're so lucky to live here. Except every few years, our particulate material spikes to devastatingly dangerous levels for a few days at a time, and then it goes over a couple of weeks, gets back down to 0 for more years to go. When does our air quality particulate material spike?
We have a fire.
When we have fires. And does everybody remember how fast-moving water can move big old stuff, but as it slows down, it can only carry the really fine sediments? We talked about that? Well, the air works the same way. So how many of you have seen during a big Santa Barbara fire, raining ashes that cover the porch and the cars, and you can see them on people's shoulders and the wind and stuff? Okay. We in Santa Barbara, we're all familiar with that. We know if there's a fire and there's ashes everywhere, that's going to be bad air quality warnings from everybody, so you know not to go jogging or whatever. And as soon as all that stuff is gone, everybody goes outside and starts running, and that's a mistake. Because those big ashes that you can see with the naked eye, they don't matter. They're too heavy for you to inhale them. If you do inhale them, they get stuck to your nose hairs and your boogers and your mucus membranes down your respiratory system. But the really fine ashes that stay suspended for another week or two that you cannot see with the naked eye, those are the dangerous ones. Because they're small enough to squeeze through all of that and get stuck inside your respiratory system. Did we talk about lungs yesterday? So you understand how there's water on the inside? And the particulates are dangerous because what? They stick. They increase contact time. It's like steeping tea. If you want, that might be a good thing for you to write down. That synergy is like a tea bag. More contact time means you make stronger tea. When the ashes get stuck to your lungs, you get more of those toxins dissolving into your blood. Whatever was bad for you gets into your blood better. Because it has more contact time, like a tea bag. Yes? Cigarettes are bad because you inhale little tiny ashes, plus a cloud of smoke that contains things which are toxic. That's why some people filter their cigarettes. You know, the cigarettes have those little... And by the way, there was a time when people would carry a long cigarette holder, which was itself also a filter, to try to trap more of that particulate so your toxic cloud comes back out when you exhale, instead of being trapped against your lung tissues and increasing contact time, which makes it more toxic. That's why filters are more helpful for smoking. Okay, anybody want to ask me anything about particulates? This is going to be fast, watch. Lead is known as plomo or plomus. It comes from transportation fuels like train and barge fuel, and I'm guessing maybe jet fuel, but I'm not an expert. Your gasoline doesn't have it anymore because it's called unleaded. So modern gasoline doesn't, but older gasoline did. And a funny coincidence, that makes your cars more efficient and last longer. Of course, the hippie environmentalists ruined everything. They made us get rid of it in gasoline. Because it's also, toxic. It causes developmental problems, brain problems, nervous system stuff. Transportation fuels, and also the metal industry. Coincidentally, most of you aren't exposed to bad air quality, and most of you aren't near a metal industry. But if you play with guns like I do, you're exposed to a lot of lead. Because when you pull the trigger, that little puff of gun smoke, that has a bunch of gasified lead. You breathe that in. Anybody want to ask me about that? Okay, please look up. I'm about to do something that you may not recognize later. SOx and NOx, what does the X stand for, like algebra? It's a variable. So that could be many molecules, SO1, SO2, SO3, SO4, NO1, NO2, NO3. They're called SOx and NOx. Also, carbon oxides are called carbon oxides. SOx and NOx come from burning fossil fuels. Anytime that you see any of these, I want you to think about the others. These are especially from coal and electricity. These are especially from gasoline and cars. And please look up. Look at all those stars right there. That means you should highlight this in your notes, circle it, exclamation mark, arrows, underline, write over it 6 times. Because forever, if you see somebody say electricity, I want you to remember, oh yeah, that's primarily coal, that's primarily SOx air pollution. If anybody ever says anything about coal, they're probably going to use that coal for electricity and it's probably going to give off SOx. Anytime you hear SOx, you got to think, oh, that's primarily from electricity made with coal. These are a direct relationship. SOx, coal, electricity, and NOx, gasoline, cars.
Not something that anything to do with nitrogen.
It actually does. Uh-huh. I believe you're referring to N2O, nitrous oxide. Whippets, laughing gas, what you put in your car to make it go faster. Is
Yeah.
that what you're referring to?
What's in like fuel tanks that like when it's more like pure?
Bro, I believe that is,
That's nitrogen. Right?
that's nitrox.
Yeah.
But if you're diving mixed gases, you shift the ratio of gases in your air intake so that you provide enough oxygen and you don't overdose on nitrogen because they have different relative pressures.
Yeah.
But yeah, that's what we're talking about, nitrous oxide, N2O. That's a greenhouse gas, actually. And these are single nitrogens with a lot of oxygen, so they're oxides of nitrogen. Slightly different compound, relatively similar. Okay. SOx and NOx, whichever is the number for the X, are byproducts of burning fossil fuels like coal and gasoline, from things like electricity and cars. They're going to come back later. They're not actually that bad on their own, but please look up. They make acid rain, number 29, and they make smog, including oxidants and sulfuric acid, SOx and NOx. So we worry about them because they are our primary pollution that makes secondary reactions in the atmosphere. I gotta clear something up about carbon monoxide. Please look up, that's carbon monoxide, there's one oxygen. I didn't write an X because CO2 is not regulated. We made up this list of criteria before the American public lost faith in government to solve big problems. This was pre-Watergate. At that time, we were worried about urban air quality, like smog and acid rain. We were not worried yet about global warming. So you'll notice that's not CO2. We don't have federal regulation of carbon dioxide. Not very much, anyway. But we have explicit, clear, finite limits on carbon monoxide because we made these when we were worried about urban air quality, not when we were worried about greenhouse gases. Well, the bottom's gonna fall, the bottom's gonna fall, the bottom's gonna fall, the bottom's gonna fall, the bottom's gonna fall. Dude, have you been in lock-off mode all the way?
Yeah,
It's so brutal on your biceps.
I'm starting to need it.
Dang, dog. That's intense, man. I guess we gotta take a burrito break for Emily Hay or somebody earlier.
It's a burrito. Burrito. It's not yours.
Did you not pay for that?
They gave me like a few extras, she said. Because they made a few extra.
Katie, you want a burrito?
Here.
Give it give it a Katie. He's doing what I said. Give it a Katie.
They made like 1 or 2 extra, not a whole lot.
Don't give them to them. They didn't pay. Give it to her.
She paid and she paid.
Fine.
And that was mine. I can't eat a burrito right now. I ate such a big breakfast, like 4 eggs and an English muffin.
He paid and he paid?
Yeah, they both pay.
Okay.
Okay,
They pay over.
And you gave her yours?
Yeah, I can't eat.
I feel bad.
You should.
No, don't feel bad.
Oh my god.
Oh, Bart.
Oh my god, don't feel bad.
It's called hugs. Amin deserves hugs. He shares food.
I'm the only
Do you
one
not
that
understand?
hugs me for your face.
Do I try
The rest
leave them
of
to
you.
cool off?
Thank you.
God damn it, Harley. Yeah.
I got, you got like 32, I think.
Awesome.
Yeah.
Oh,
Oh, that sucks. I didn't mean to mess up your video game, Pierce. Bro, I'm sorry to wreck your drifting. Alright. Now, back to carbon monoxide. Carbon monoxide is different from carbon dioxide. Carbon dioxide is what happens when you break carbon bonds. Please look up. Like gasoline around oxygen makes CO2. The reason that you need oxygen, does anybody remember from Ecology 101 at the very beginning of the year, Unit 2 or 3 or something? Shut up, Kylie. Bob. Shut up, Bob. The reason you need oxygen is so that you can distract those single carbons and exhale them out conveniently. You only use oxygen so that you can break your carbon bonds and get the energy so you can run around and kick your sister. So, please look up. Gasoline, break carbon bonds with oxygen, stick the carbons to O2, and you make CO2. But, here comes the key part. Gasoline with less oxygen makes carbon monoxide, and that's toxic. How many of you have heard that you can commit suicide by closing the garage and running the car with you in the car and the windows down inside the garage?
Wouldn't you need like some hoses?
You need to like
Perhaps you've heard a variety of methods that are supposed to make this work better. How many of you saw that famous scene in House of Cards where, spoiler alert, that guy kills that guy? Yeah. Now back to me. Newsflash, if you plan to kill yourself, the thing with the garage won't work.
Oh. Wait. I saw a movie and the dude like put something in this guy's tailpipe and like put it into his car. Did he channel it directly into his car to lift it up and that way?
The little gap where you put the hose through,
I mean, like take the raspberry and he said he can do that.
you might, maybe. It'd be pretty tricky.
Put the hose in your mouth.
My hunch is in most modern cars that wouldn't work anyway. But here's the bottom line. The reason that your modern car won't do this is, watch me, those darn hippies ruin everything. Nowadays, your car has a carbon monoxide detector in the exhaust pipe. When your engine has insufficient oxygen to make it CO2, it makes carbon monoxide. And that sniffer says, whoa, open up the oxygen supply, close off the gasoline, so that we keep the right mix and all of your carbon has to come out as CO2, which is not toxic, instead of carbon monoxide. So what would happen in your garage with your car, assuming it's younger than 43 years old or something? If your car is less than 43 years old, your oxygen would get used up burning gasoline and it would make a bunch of CO2. As oxygen levels started to drop, you'd get a little sleepy. Your body would shut down your consciousness because that's not a critical function. Running on low oxygen, you would still be alive when your car started to sputter and it would eventually stall. Because your car refuses to make carbon monoxide. And so you would wake up with a horrible headache. You probably soil yourself because as your body soaks up all the oxygen to keep your brain working, it relaxes all of your muscles, including, all of your muscles. And you'd have to explain to your parents why you had such a big headache and had to soil your pants. Modern cars don't make carbon monoxide. They'll turn off before that happens. So, the only way that you can get carbon monoxide, I told you that whole story because there's a key concept, is this. Incomplete combustion, like smoldering. When stuff isn't burning really hot, when it's just kind of like fizzing burning. Like when people have crappy wood-burning stoves. Like when there's not enough circulation and you're running like your propane heater inside of an RV or something. That's when carbon monoxide actually happens, incomplete combustion. Anybody want to ask me about that one? Finally, ozone is the 6th criteria pollutant. Remember, please look up, that's a secondary pollutant. We don't do anything that makes ozone directly. We make the ingredients, they go party in the atmosphere, and then ozone is made by the atmosphere. That's bad for us. So please look up, we regulate the ingredients to make ozone, not the ozone itself. Also remember, we're only worried about ozone if it's near us. Remember I showed you the very beginning of the unit? One of the 6 things you have to notice about our atmosphere is that most of the ozone is at the top of that teardrop spinning top shape. Remember that, the blue thing? We don't have too much ozone down here. That's not the stuff we regulate. Pierce, put your phone away, bro. Too much. No, not on another part of your table. Thank you. There is something else that we regulate, but not directly as one of the 6 criteria pollutants. They're called volatile organic compounds. This was your warm-up yesterday. What does volatile mean? Like a person who's volatile? He or she is emotionally unstable. That's a good way to say it. And organic means what in the chemistry sense? What? Carbon. Has carbon in it? So look at me. These are unstable or reactive carbon compounds. Little hydrocarbons, little bits of carbon chain that are chemically active in the atmosphere. They make reactions. They're unstable. They find something else and go, hey, you want to party? They like trade atoms. Chemistry happens. Yeah.
Wait, all of those are VOCs?
Not these. That's a category of hydrocarbons. It's any little carbon chains that react in the atmosphere. There are literally thousands of different VOCs.
Is that a criteria?
There are criteria for them. So look, everybody stop. I got to answer Bob's question so that you all understand. There are 6 of the original criteria pollutants, and then, in addition to that, there's one category of chemicals that's kind of regulated by a bunch of other laws called VOCs. There are other criteria for VOCs. The 6 federally regulated, and the ones that are kind of regulated separately. You have seen volatile organic compounds in your life. Anytime you saw something changing phases quickly, usually they have a strong smell. When fiberglass hardens on a boat or a surfboard, when spray paint dries, when fingernail polish hardens on the fingernail, or when acetone liquefies and removes fingernail polish, when PVC glue goes on as a liquid, melts the plastic, and a few minutes later it's rock solid. You all notice that those experiences have a common strong fragrance? You're smelling volatile organic compounds. They're little bits of hydrocarbon. When you do rapid chemistry, there's going to be some chemical chunk change left over. That's actually like a really fast reactive environment. So little pieces of hydrocarbon go off in the air, those are VOCs. This also includes, by the way, natural gases like methane, butane, propane, those are reactive. Those are little chunk change of chemistry. Yeah?
What's that?
From. So these come from fast chemistry. These happen in nature. Can you all think of something which is liquid and becomes solid in nature? Associated with trees. Sap. So when sap dries, you actually release little tiny bits of VOCs. But the sap dry right away or does it take a while? So not as many VOCs. Does that make sense to everybody? Saps which dry really quickly have the most VOC. Yeah?
Wait, so hydrocarbons and natural gases are like different areas of VOC?
Right, they're different types. Yeah, technically hydrocarbon is a generic term for anything with carbon and hydrogen. So technically hydrocarbon includes the volatile ones and it includes the natural gases. So that's probably the most generic term. The reactive ones are VOCs. That answer your question?
Yeah.
Ask me something about this, or we're going to do acid rain. I'm going fast because I can't have you guys be this far behind. Ask me. So, number 29 gets 2 stars. Acid rain and stuff. It's not just rain. Fact number 1 that your book may not have told you. There's acid snow, acid hail, acid fog. There's even acid dust. Because raindrops evaporate when they fall through hot air. And they leave little acid crystals that rain down just as dry acid precipitation. Trippy, huh? Why, hello. So nice to see you. Please note, all rain is acid rain. As you know, oxides and water makes acid, and as you know, our atmosphere always has a naturally occurring oxide called CO2, carbon dioxide. It's always there.
Yeah.
So please look up. All rain has this weak hydrochloric acid. It's not that bad. So all rain being weakly acidic doesn't really matter much. It doesn't affect you or anything else. Who cares? But sometimes humans add unusual oxides to the atmosphere, like NOx and SOx. And those SOx and NOx mix with water to make nitric sulfuric acid, which are very strong. Sulfuric acid is the more stronger one, yeah.
Is that, can that be naturally occurring?
Oh yeah, yeah,
Volcanoes? Yeah.
exactly, yeah. Volcanoes pretty much make anything you can imagine. So there's like a chemical compound and you want to just guess where it's made, you should just guess volcanoes. You're very likely to be right if you say it's possible in volcanoes. Tons of energy, right? So, there's a few problems that come from acids. You have to know them. I can think of 5. Number 1, it changes the pH of soil, which really affects soil ecology, like microbes and bacteria and decomposers and stuff. Soil pH is number 1. Number 2, it's damage. Oh yeah.
I was gonna ask if it affects the ocean.
Absolutely. We are acidifying the ocean very much. Because we've added so much of this that the ocean's getting more acidic. Plus these making the ocean more acidic. But here we're talking about acid rain on land. Problem number 2, aquatic species get messed up by changing the pH, but do I mean ducks and like surfers and stuff?
No,
Why not? Which aquatic species am I thinking of?
like,
Breathing and breathing.
Yeah, what Emily said. Breathing and breeding, the 2 B's. If you what?
what is that mean? What is that referring to?
Well,
All the aquatic animals and.
there's actually a lot of aquatic animals that don't breathe in water, like whales are aquatic, but they breathe internally and they breathe the atmosphere, so they don't really care about the pH.
So it's just all fish and stuff with the.
Fish, amphibians, and some aquatic insects, and that's kind of it. Things that breed or breathe in water. Number 3. This is a hard one to explain, so I gotta tell you a story and then I'll give you the part you write down. But I hope you all understand this because it's got a lot of little details. First of all, some elements are toxic. Do you realize that? Like arsenic. There are toxins in nature. There's another fact that you probably know, which is that rocks fall apart when it rains. They weather. You understand that? Mechanical, physical weathering of rock. Fact number 3, before you start writing anything, acids speed up the weathering of rocks. So the part you have to write down, the 3rd problem with acid rain, increases concentration of toxins in runoff if they are present in the rock.
Why do we think of
Because rocks contain a variety of toxic things, like our sandstone has kind of high levels of uranium. You know, it's not crazy high, but if you wear out the rock twice as fast, our creeks would have twice as much uranium, right? Because the water would have the same volume, but double the uranium dissolved in it.
Yeah, I get that. I guess I'm more interested in how those elements get into the rock in the first place.
Well, they're all, if you take any of the naturally occurring toxins, they're going to be found in something, right? So there will be some sedimentary rock which contains toxins. It's like, how does the carbon get into the rock? Like, I don't know, rock cycle, deposition, capture. Number 4. Imagine if your bedrock contained a bunch of lead. Like, you know that lead's found in the ground. You went to the rock factory, got more lead in the runoff. Number 4. Acids destroy building materials. Like paint, steel, concrete. I felt totally ripped off because I went to go see Michelangelo's David. I believe I was in Florence. And I was so excited, like, oh my God, it's the David, it's the David. And I stood in line for like 4 hours, and when I got there, they had it covered up in plywood. So you had to like step in this little tiny plywood shack because they were keeping him out of the rain. He was outside for like 400 years. And so the top of his head was pitting as the termites were eating because the acid rain was soaking in the marble every time. And after the water evaporates, the acid crystals are left. So once you start making those little termite holes, it just traps all the acidity without, the water will evaporate, but the acid crystals are left. So when it rains, it all dissolves and becomes super acidic. So you get these like pits. And those are happening in like towers, high rises, bridges, famous sculptures. Anything left outside will eventually start to dissolve because of acids. If we add more acid, it happens faster. This is a fact. There's a thing called the Rust Belt, which is like the industrial part of the United States. And partially when using metals outside, they get rusty, but one of the main causes of rust corrosion is increasing acidification of rain from all the factories. So when we built all the factories in one place, we created acid rain that we had to rust more than usual. That's the rust problem. Finally, number 5, acids can be bad for you, especially if they're carried by particulates. You should know about why the particulates. They increase contact time like steeping tea. Now, I don't expect that we will catch up with my other period, but I'd like to explain an important principle of chemistry today. How many of you have had chemistry? Because a lot of you have not. I'm going to explain this important principle in simple metaphors that you can understand. Please look up. How many of you have heard of Hofbrinkel? What are the Hofbrinkel? By the way, everybody else, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. You probably knew most of those. If not, you can write them down. You'll need to know this. I'm going to ask you to take some notes on this. Hofbrinkel is hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And you probably knew those, so you don't have to write it down unless you have one you didn't know. Everybody knows hydrogen, I think. Everybody knows oxygen, I think. Everybody knows fluorine, I think, because it's the only one that starts with an F. Bromine might be tough, so you might want to write down that one. It's the one that was in solar panels, and the one that's in nuclear reactors to absorb neutrons. Twice you've seen bromine so far in my class. Yeah, we're kind of building the foundations of knowledge to understand 30, yes. Iodine, nitrogen, fluorine. Okay. What's special about those 7 gases, chemistry nerds? What? They're like diatomic, yes. What does that mean? What do you mean there's 2 of them? One molecule is 2 atoms? Why can't you have one molecule of 1 atom?
Well, I don't know, but then again, they bond to other things really easily.
They do bond to other things really easy. They bond to things pretty much all the time. Why? Watch, everybody. I'm going to piece together what the other kids have said with something you'll have to write down. These, on Earth's atmosphere, cannot exist alone. Party foul. Thanks, Cole. They are diatomic, which means they cannot be alone. They're desperate. They're clinging. They make bad decisions. You probably know somebody like this. Don't point at him or her. But you probably know somebody who is clingy and desperate and cannot be single. Hop out of one situation and immediately jump into a new bad situation. And I'd like to show you an example using oxygen. That's difficult for you to explain with chemistry terms, but you can describe the behavior thinking about it in relationship terms. I need 3 volunteers. Don't go at once. I need 3 volunteers. Come on. Hurry. I need 3 volunteers, please. Get up here. Okay, there we go. Aaron, Tim, and Serena. They are all oxygens. And for the sake of conversation, I could be oxygen, but I could be all sorts of other stuff. Now, we as oxygens cannot bear to be alone. We're desperate. We're clingy. I got mine. You guys can't be alone. Come on. Come on. There we go. All right. Now, Serena wave. Tim wave. Each of those single oxygens that are now happy because they're in a relationship. Smile. Smile. There we go. Aaron wave. Single oxygen. Me, I wouldn't be oxygen right now. But I could just as well be another big old molecule. You know that I count for like 5 high school kids, right? You all know that. I think Dub's bigger than these kids. So I could be a big molecule, or I could be a single oxygen. It doesn't matter, because I'm happy, and Aaron is happy. All of them. 14. Yeah, there we go. See, he's happy, because he's in a relationship too. We are all fulfilled diatomic elements. This is what happens in our understanding of the Earth. This is nature. That's why oxygen is always written O2, and nitrogen is always written N2. And in case you're curious, all the Hofsprinkles are always written with a little 2 after them because they're diatomic. You never find them as singles on Earth. Are we clear about that fact? Hofsprinkles can't be single. You have to have that written down. They're diatomic. You have to have that written down. Now, let's imagine that something happens over here where perhaps I am distracted by a chemical reaction or an extreme force like a lightning strike or something, and I am still happy because I got something else going on. But what's going to happen with Aaron? Oh my God! He's freaking out. Freak out, Aaron. Freak out, freak out, freak out, bro! You gotta find something, bro. Get it, Aaron. How about him right now? How about him? Get him! Alright, now. Loving, over here, sir, also you too. Okay, children, that is ozone. Ozone. 1, 2, 3 oxygens. Look, they're all kind of happy, right? Kids, smile the audience. Kind of happy. What you might imagine, though, is Tim's not quite as happy as when he could focus on Serena. Serena's not quite as happy as when she could focus on Tim. And Aaron, he knows this isn't really gonna last very long. This isn't gonna work out. You understand what I'm saying here? First of all, I've created ozone. It's a group of 3 oxygens. Second of all, this is inherently unstable. This isn't going to work out. You may have heard that relationships of 3 really is not good. You might also imagine that if they're truly desperate and they're truly single, they really wouldn't care who they got rid of. The bros would be happy. Serena would be happy with Aaron. Serena would be happy with Tim. Doesn't really matter. But if they could get back to 2, that would be better. We'll come back to this scenario on Thursday. Good job, children. Very good. Please don't be absent on Thursday. I'll need you to pick up right where we left off. Bye, children.
Oh, dear. I made this dumb thing last night. You don't have a pulse yet?
Will you press the red button for me?
Oh, yeah. You want to pull?